Welcome back to the Advanced Arduino Basic project, and today we will learning about multi-sensor data logger system. Here is the agenda: overview, components, principle, schematic, procedure of multi-sensor data logger system. So in this lesson we will program the Arduino to implement a multi-sensor data logger system using Tinkercad simulator. The system continuously monitors and records environmental data by processing inputs from multiple sensors. So here we using temperature sensor, LDR, force sensor, soil moisture, gas levels and distance sensor. So what are the components are required? Arduino Uno, ultrasonic sensor, gas sensor, temperature sensor, soil moisture sensor, force sensor, LDR, resistor and jumper wires. So the system works on the principle of sensing, signal conversion and data logging. So the sensor detects environmental parameters and convert them into electrical signals, which are processed by Arduino and displayed as readable data for continuous monitoring. The system operates continuously in a loop to ensure real-time data collection. So this enables efficient monitoring and analysis of environmental conditions for various applications. So this is the schematic diagram and this is the circuit diagram. So here you can see this is ultrasonic sensor, force sensor, gas sensor, soil moisture sensor. Then this is LDR and this is the temperature sensor. All are connects to the Arduino Uno microcontroller, and this is the program. So the first step is the pin declaration of sensors: temperature sensor pin, then light sensor, force sensor, soil sensor, gas sensor. So here we connected pins. Next is the trigger pin and echo pin. So these are the pins of ultrasonic sensor. So here we connected this both to the digital pins and the rest sensors are connected to the analog pin numbers. And this is the variables. Long is a data type and duration. Float is a data type, centimeter, then inches. So void setup. So this is a setup function. It sets all sensor pins as input and starts serial communication. So here we use it serial.begin of 9600. So next is the loop function. So here you can see temperature reading equals to analog read of temperature sensor. So it reads value and converts it to temperature in degrees Celsius. So it will using voltage, first finding the voltage value by using temperature reading, then converts into temperature in degrees Celsius. And here you see the light sensor related code. So it reads the light intensity value and it reads the force or pressure value and it reads the all soil wetness level, and this one for gas concentration level, and here you can see the distance measuring. So it sends signal. So here you can see it sends signal, then calculate distance. First it will find the duration, then by using that it convert the centimeter distance and next convert the distance into inches. And here you can see data logging output. So here we using the serial monitor to display all sensor values, and here temperature, light, force, soil moisture, gas level, then distance. And we also using the delay here, waits 1 second before next reading. So that's all about the code. Now we need to do the circuit diagram using the Tinkercad simulator. So what are the required components? Let's see in the circuit diagram. So first we need Arduino Uno, then we need one breadboard. After that we need different sensors, ultrasonic sensor. So we need not this one, trig and echo pin, ultrasonic, 4 pin, right? So here we having 4 pin. Next we need temperature sensor, photoresistor, temperature sensor. Then we need gas sensor, then moisture sensor, soil moisture sensor, then force sensor, this one, then photoresistor, temperature sensor, force sensor, ultrasonic sensor, gas sensor. That much. Now we need to connect ultrasonic sensor first, only this much, right? And we need 3 resistors. We'll take it from this. Okay. So now we need to do the connection of ultrasonic sensor. So the first pin is VCC, right? So here we need to connect this to positive rail, and ground pin I am connecting to the negative rail of the circuit, and this is the positive rail, not circuit, breadboard. Then trig pin. So here I am connecting this trig pin to the digital pins. So this pin I am connecting to pin number 2. Then this echo pin I am connecting to pin number 7. So this is pin number 7. So now connection is over, ultrasonic pin connection over. Next, gas sensor. So here I am connecting this to, it's difficult to connect, I'll connect like this. So how to connect this gas sensor? So this is A1, right? So I'm connecting this to 5 volt. So this is positive rail. I'm changing this to red color. Then this pin. So I'm connecting this to 5 volt again. This is done, and below part, this one I am connecting to A4. So here it is. Next, the second pin I am connecting this to ground. So here, negative rail of the breadboard. That's all. Now here B2, B1, right? So we need to connect this pin to So how to connect? See here, we need to connect this to here, then we need to connect, yeah, let's connect it to ground, then short this, yeah, we need to connect this to ground. So this is ground. So that is gas sensor connection. Gas sensor, ultrasonic sensor done. Now temperature sensor. So here it is free, right? Yeah. So this is power pin. So I am connecting this to delete it. We'll connect this. I'm connecting this to here. Power pin, right? So positive. Then this is ground pin. So here I am connecting this to negative rail of the breadboard. Next, this pin, I am connecting this to the analog input. So A0. This is the A0. And I am changing the color to green. Yeah, this temperature sensor connection is over. So now we need to connect the force sensor. So I am placing this to here. This first terminal. So let's connect this to positive rail of the breadboard. Then this terminal. So I am connecting this to analog pin A2. So this is A2. And we need to connect resistor to this 8. So it should be 1 kilo ohm resistor. I forgot to tell that it should be 10 kilo ohm resistor. Okay, yeah. So force sensor connection done, temperature sensor, ultrasonic sensor done. Now photoresistor. So I am connecting this to here. So it should be connected to the positive rail 5 volt. Then we need one 10 kilo ohm resistor. Then we need to connect this to ground. But before that we need to connect this to A1. Yeah, see how it is connected. This one. Next pending is this one. Yeah, plus this is VCC, right? So ground pin. So I am connecting this to negative rail. And this is 5 volt positive rail. Then the signal pin, I am connecting this to the analog input A3. So here we having A3. So this is A3, right? Yeah, connection part is over. Now we need to write the code. Choose text, continue, then code. Now start simulation. We need to observe the output in serial monitor. Let's see, everything is fine, right? Yeah. Now check it in here. It's not showing. Yeah, showing. Oh, we forgot to connect the ground pin and supply, right? So this is positive rail and this is negative rail. We need to connect this to ground. So here we having ground. Then we need to connect the power pin also. So power positive. So here it is there. Yeah. Start simulation. Yeah. See here. Temperature is showing. Then see, temperature, light, force is not showing. Then soil moisture, gas level is there, distance is there. Start simulation. Force, you just apply force, apply the force, then check the output. Yeah, see, force also showing. Now soil moisture sensor, just vary it and observe the output. Similarly, you can change all the values. Now see here, distance, vary it and see, value is changing now. It should change. Yeah, it's changed. Similarly, force, vary. Yeah, it's having 355, right? Now we vary. Now it's 451. Similarly, moisture. So it's having 233. Now it's changed to 816. And this just vary. Now it's light value should change. 54. Initially we had 54. Now 956. And temperature value also vary. And see the changing. And gas level. So all values are changing, right? So you can see the output in the serial monitor showing values from all sensors. So each parameter such as temperature, light, force, soil moisture, gas level and distance is printed in a readable format. The values update continuously every second, allowing real-time monitoring of environmental conditions. The temperature is shown in degrees Celsius. The temperature shown in degrees Celsius, right? Here you can see. Then distance in centimeters and inches, and other sensors display analog values. This helps in understanding the changes in the environment based on sensor reading. So that's all about the multi-sensor data logger system. For more project, please watch the upcoming videos. Thank you all.